Hello. Hello, Dimesha.
Hi.
Sorry about the delay.
Oh, that's okay. We're good.
I thought I sent the code and I was waiting and realized that didn't send. Sometimes that happens, you know. Just have too many things in my mind, so
No worries.
we'll just wait for. Anna has logged in, right? Alrighty. So what should we do today?
I think Anna and I have just gone through all of our chapters, and we've starred or like noted the ones that we were like struggling to answer.
Mm-hmm.
I think we were going to go through Anna's first.
Okay.
I think they're in 18F. I'm pretty sure that's what she said.
18F, is it?
Yeah. Or 18.
All right.
Yeah, something like that.
Let me just load up the books here. So it's the pink book still, right?
Yeah.
Yeah.
Hello.
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 How are you?
Yeah, I'm good, thanks.
Can you guys see the pink book here?
Yeah.
Yeah.
Okay, so what chapter, Anna?
Hang on, I'll just get my math stuff. Yeah, it was 18F.
All right. Mm-hmm.
Yeah, so generally it was okay. I just had a couple of questions about question 3E.
This one here, is it?
Yeah. I'm not sure how to work out E. Yeah.
Okay.
So yeah, so I have 4 questions
Sure.
in that chapter. Yeah.
Right. Okay. So this is the displacement versus time there, and question E here says the position of the particle x in the time t seconds is given by the rule of the form here, which is a quadratic equation, right?
Yeah. Yeah.
Yeah. Okay. Just give me a second. Yeah. So I think the easiest way to do this is a you can see that this is a quadratic formula. So there are a few quadratic forms, right? Which is ax squared plus bx plus c. That's the general form. The second one is a and then x minus alpha, x minus beta. And the third one is a and then x minus h squared plus k. So this one is, the last one is good for the vertex. If you know what the vertex is, then you can take this one and all you have to do is figure out a. If you know what the x-intercepts are, then you know what beta and alpha are, so you can just figure out what a is. This one is what you get pretty much when you expand this one out, okay?
Yeah.
So what's the advantage of the general form? That's useful when you know the y-intercept. Well, that only gives you information about c. C is the y-intercept there. So basically, I think I want to use this one here. Y equals to, hold on, this is now x, right? X is equal to a. And this would be t minus 0. And then t minus 4. Is that right? You can stop me anytime if you don't understand, okay?
Okay, so wait, those are just the x-intercepts?
Yeah, the x-intercepts are 0 and 4,
Yeah.
isn't it?
Yeah.
So this is a here and then t here. So I can just write this bracket as just t and then a t minus 4.
Yeah.
And then I want to figure out what a is. So to do that, you need to, did you figure out the top here, the vertex?
Yeah, that's just 2.
So was that 2 and 8?
Yeah.
Yeah. So that means it goes through that point. So you use that point. Figure out. So this is a here, and then a here, and then 2 here, and then 2 minus 4. So 8 here, and then this one is negative 2. So it's negative 4a. So a equals to minus 2.
Yeah.
So from this, you figure out x is equal to minus 2t minus 4, but you want this to be expanded like that, right? So this is a negative 2t squared. This times by this is plus 8t. So therefore, this is p value here. P is negative 2. Q is 8. And then R is 0. We check the answer?
Yeah.
So this is a 18F, question 3E. 18F, question 3E. So negative 2, 8, 0. Negative 2, 8, 0. That's right.
Oh, okay.
So another way of doing this is use this one here. So I'll show you how I can do that one. So that's the vertex form. So x is equal to a. So this will take the x value. This will take t value, right? Because you got y-axis is x and the x-axis is t. So x is equal to a and then t minus h squared plus k. We know that the vertex is 2, 8, right?
Yeah.
So plug in 2 into here and 8 into here. So you get x is equal to a, t minus 2 squared plus a. All you have to do is just figure out a, right?
Wait, so how do you know h is 2?
Because of the vertex. H is the x coordinate of the vertex. K is the y coordinate of the vertex.
Yeah.
So once you have this is your equation of the parabola. But the only thing that's remaining to figure out is a, right? So you can figure this one out by plugging in any point other than the vertex.
Oh, okay. Yeah.
So because we already plugged in pretty much when you plug in 2 and 8, we already used that point, right? So to figure out a, you have to plug in some other point. In this case over here, see how we already used the x-intercepts? So to figure out the a value, we have to plug in some other point other than the x-intercepts. So just opposite process, isn't it?
Yeah.
Does that make sense to you?
Yeah, it does. Okay.
So if you plug in, I'm going to plug in 0, 0 into this vertex form. So this is 0 here, a, and then 0 minus 2 squared plus 8, because it goes through the 0, 0. And then 0 equals to a. This is 4 plus 8, so therefore a equals to minus 2 as well. So plug that in, then you get equation of x is equal to minus 2, and then t minus 2 squared plus 8, right? And then if you expand this one out, you get the same thing. So this is negative 2 here, and then t squared minus 4t plus 4 plus 8. Expand this one out, negative 2t squared plus 8t minus 8 plus 8. 8 cancels out. Same thing.
Okay, yeah.
Yeah. So I hope my explanation wasn't too fast, because I want to cover as many questions as possible. But if you want me to slow down, that's fine. You can always tell me to slow down. Was F all right?
Yeah. You just plug in t equals 3 in the velocity.
What should we do next? Should we do the meshes question, or should we just finish Anna's question first?
I don't mind either way.
Okay.
Yeah, I don't mind either.
Yeah.
If you just want to go through all the ones in 18F, then if you haven't answered my ones, then I'll say.
All right. So let's go through Anna's question first then. Yeah.
So question 8.
From 18F, right?
Yeah.
This one here?
Yeah. Just for C, like the work, I worked it out and it was okay, but I was just wondering, why can't you plug in, I'm not sure how they worked out C, actually.
All right, so there are a few ways of doing it. First way is you plot this one. So x is equal to t squared minus 7t plus 10, right?
Yeah.
Can we factorize this one?
Yes.
So this is very easy to plot. It's t minus 2, t minus 5, right?
Mm-hmm.
So this is 2 here. This is 5 here. And what's the y-intercept?
Is it 10?
10, that's right. Because if you let t equal 0, 0, you find x is equal to 10, right?
Yeah.
So that value is the y-intercept. In this case, x-intercept, right?
Yeah.
And that's time. So it's a parabola. This is a parabola and looks like this. And so once you do that, then you can find that if you draw the number line like this, it starts from here. This is 0. It starts from here and then goes down to some point, which is this point here, and then goes back up to 0, right?
Yeah.
So what's the distance? You have to measure that distance plus that distance. That's going to be the distance, right?
Yeah.
So we can take the derivative of this one. So take the derivative. You guys learned derivative, right?
Yeah.
Yeah.
Of course, yeah. dx dt is equal to 2t minus 7, and let that equal to 0. When you let the first derivative equal to 0, then we are looking for stationary point, either maximum or minimum. So t is equal to 7 on 2 from this equation here. That makes sense. This one is a 3.5. That's when we have a stationary point. Now, we plug this back into the original equation. So x is equal to 3.5 squared minus 7 times by 3.5 plus 10. And what we get from there is why is it so small? What happened to this calculator? Hold on. You guys can still see it, right?
Yeah, I can see.
3.5 square. I think it's the resolution. I think something happened today with my computer. So that's, hold on, that's not right. 3.5 square minus 7 times by 3.5 plus 10. Then you get negative 9.9 on 4. That's negative 2.25, right? Negative 9 on 4, that's negative 2.25. So it means this position here is a negative 2.25. So this one is starting from 10. So that distance is 12.25, right?
Yeah.
Plus that point, that value is 2.25 as well. The total distance is 15. So that way, 12.25, 2.25, so it's 15.
Okay, so
14.5, sorry. 14.5.
Yeah.
Yeah.
Oh, wait, where did you get the 12.25 from again?
That's 10 here.
Oh, yeah.
So you see from here to here is 10.
Oh,
From
yeah,
here
I
to
see.
here is 2.25.
So why can't you just sub 3.5 seconds back into the original equation?
You can. But you were trying to figure out distance traveled in 5 seconds, is it right?
Yeah.
Trying to figure out 5 seconds. So you want to go from here to here.
Okay.
So by the time you go to, by the time you reach 3.5 seconds, you have been only moving downward. So by the time you get 3.5 seconds, then you're down here. But then when you reach 5 seconds, you're back to the origin.
Yeah, okay.
Does
So
it
you
all make
can't
sense?
so you can't plug 5 seconds into the original equation?
So what happens if you plug in 5 seconds in here? You get 0, doesn't it?
Yeah.
Yeah.
Oh, yeah.
Yeah. So here's what you're doing. So if you do x of 5, so this is pretty much 0, isn't it? What this means is that displacement, which means the current position, okay?
Yeah.
Position is 0 meters, which means at the origin, when time is 5 seconds. So this is not distance at all. This is absolutely not the same thing as distance. Okay.
Oh,
we
I
talked
see.
about 3 things before, right? We talked about distance. We talked about change in displacement, right?
Yeah.
So you can so displacement, when you plug 5 into the original equation, that's you're trying to figure out where the particle is when time is 5 seconds. So that absolutely doesn't tell us anything about how much it traveled.
Yeah, okay, I get it. Yeah, that makes sense.
So there are 2 things. There are 3 things actually. So one is displacement. That's about the current position. You just have to plug in time. There is something called change in displacement. This gives you the average velocity, right?
Yeah.
So change in displacement is the final position minus initial position. So final position was 0, isn't it?
Yeah.
Because we are looking at 5 seconds, right? So final position at 5 seconds is 0, but initial position is 10. So change in displacement is minus 10. But distance, you really have to, so this is the most difficult, I would say, the most difficult to deal with in this module and this session. So this is what you have to be most careful about. Distance is you just have to, it doesn't care about positive or negative. You don't, you take everything as positive. Okay. So to do distance, you have to draw a diagram.
Yeah, okay.
Draw a diagram. Second, add all the parts, okay?
Yeah.
As positive. So that's in this case, it was equal to 14.5 meters. So from change in displacement, we get the average velocity. Average velocity is change in displacement over change in time. So that's equal to minus 10 over 5 seconds. So that's minus 2 meters per second, right? That's how you get the velocity. And the speed is distance divided by time. So that's equal to 14.5 divided by 5. Okay? Now, here's how you do distance. I'm just going to write it down here, just quickly. If find distance if there exists a turning point so how do you find turning point? You let the dx dt equal 0. Exists a turning point, you have to draw a diagram. Which means this is x. It starts from somewhere, goes around, turns around, so that's a turning point. This is final position, right? Then you have to, or you can do it like this. This is time here, x here. It starts from here and then goes around here, and then starts from here and then go like this and then come back here. See? That's a turning point here. So if there's a turning point within your time interval, so our time interval was 0 to 5 seconds, wasn't it? If this is the case, then draw a diagram and then add all the paths. Okay, that's what you have to do. And this will be the case most of the time when they ask you distance. Now, if no turning point, then absolute value of x final minus x initial will be your distance. So change in displacement, the absolute value of it will be the same as your distance. Okay?
Yeah.
So I'll give you some example and tell you what it means. Have a look. What's here, and then here, and then here? This is a 15, this is a 7. So what's the total distance?
Oh, wait, so it's just 15? Plus.
I'm going to give it time as well. This is 3 seconds and this is 5 seconds. So what's the total distance? I want you to work it out and figure out the change in displacement. So, Anna and Nimesha, what's the distance here?
Just would it be 20?
I don't think so. You go up 5 and then down 8.
Oh, 13. All right, yeah.
So it's 5 plus 8, isn't it?
Yeah.
5 plus 8. So it's 13, right? What's the change in displacement?
3? No,
Negative 3.
negative 3.
It'll be 7 minus 10. Final position minus initial. That's a final position here.
Oh, yeah.
And this initial position. So that's equal to minus 3.
Yeah.
All right. So this is over 5 seconds, right? So if you divide this one by 5, then you get speed. Average speed. If you divide this one by 5, then you get average velocity. Make sense?
Yeah.
Now have a look at this one here. Is there any turning point?
Oh, wait, which one?
This one over here.
All right, yeah.
Is there
No.
any turning point? No. Now, what is the distance? Just 10.
10,
What about
yeah.
change in displacement?
Negative 10,
20 minus 10, right?
20. Oh, minus
Final
initial.
minus
Yeah.
initial. So it's 10 as well, you see? So if there is no turning point, distance is actually the same as the change in displacement. When do they differ? Only when there is a turning point.
Mm-hmm.
Only when there is a turning point. Now, have a look at this case as well. This is 20. This is 10. This is 5 seconds. Now, what's the distance?
20. I mean 10, sorry, 10.
10. Positive 10, right? What's
Yeah.
the change in displacement?
10.
Negative 10.
Negative 10.
Okay. In this case, they're different, right? But only by a negative sign, true?
Yeah.
That's why in the formula here, I wrote down, if no turning point, the absolute value, so they will have the same size. That's what I'm saying. They will have the same magnitude. This could be minus 10, but this will be 10, right? But the point is, if there is no turning point, distance and displacement will be of the same magnitude. Does that make sense?
Yeah.
Yeah, they're not different. So you have to, when it comes to distance question, first thing you have to do is find turning point and see if turning point is within your time interval. If it is, then you have to draw a diagram and then figure it out. If you see that there is no turning point, then just figure out the change in displacement. Plug in the original time, plug in the later time, and then figure out the final position, and then minus the initial position. All right, let's move on to the next question.
Yeah, so it was at question 10. It's actually got
Yep.
a distance question in it
Distance
as well.
question as well?
Yeah.
Okay, let's have a look.
So my teacher said that we should definitely do this question because we're going to get a similar one in the exam. And I don't think it has it on this question, but I know the answers work out the distance. And
Yeah, because
maybe,
there's an average speed. If you want to know average speed, you need to know the distance, right?
yeah.
5 seconds.
Yeah. My question, oh yeah, it was just about F. I just asked what if the displacement changed? Because I know in the question it says it's a straight line, but if the displacement changed, how would we work that out differently?
Okay, I'll just have a look at, I don't really understand where you're getting lost. So let's just do it all together. So initial position is 12, right?
Yeah.
Because when time is 0, 0, then x is 12. What is its position at t equals 5? Then you just have to plug in 5 in here, right?
Yeah.
So that's, if you use calculator.
Should be 2, I think.
Is it 2?
Yeah.
That's 25 minus 35 plus 12. So it's 2. So that's the position at 5 seconds, 2. So at the moment, we see that it starts from 12, isn't it? And then 5 seconds later, it's at 2. Is that right?
Yeah.
Now, find its initial velocity. So just take the derivative. So dx dt, so that's the velocity, which is equal to 2t minus 7. And then you have to plug in 0. Is that right? What's a v of 0? That's equal to negative 7. So that's negative 7. It means it has negative gradient, so it goes down like this.
Yeah.
And then when does the velocity equal 0? So let this equal 0, velocity equals 0, then you get t equals 3.5. So around 3.5, which is around here, then you have a zero velocity. So the gradient will be 0. And what is this position in time? So you plug in 3.5 into the original equation to figure out where it is. So it's a 3.5 square minus 7 times by 3.5 plus 12, right? Then you get negative quarter, negative 0.25. So it's actually down here. So this is a position versus time. It starts from there, and at 3.5 seconds, it is negative, which is a negative 0.25. And then it has a 0 velocity, so the gradient must be 0. So it must be a parabola like this, 0 velocity, and it shoots back up again. So that's what it looks like. So that's all done. D is done. What is the average velocity in the first 5 seconds? Well, average velocity is change in displacement, right? So 12, 2. Just initial final position minus initial position. That's 2 minus 12. So that's equal minus 10. So the answer is minus 10 on 5. So it's minus 2. That's the velocity. No, speed is very simple, right? It goes down and then up. So you guys can figure it out. I'll give you some time. Okay. Can you guys work it out? Yep, just take your time.
Is it just the same as? Oh no. Yeah, so this is where I got a bit confused because I wasn't really sure what to do because the answers worked out the distance.
Yeah, so you have to work out distance. In order to work out speed, you need to work out distance, right? Distance over 5 seconds. So the question is, what is the distance? Just take your time. Nimesh, you can try as well.
Yeah. Is it 14.5?
14.5, all right. So 14.2, hold on. 12.25 plus 2.25, that's right. So it's 14.5. See? So you figure out that distance. How much is that? 12 point? Yeah. That's 12.25 plus that. That to that, right? That's 2.25. So that's equal to 14.5 divided by 5. Is that the answer?
Yeah.
Have you checked the answer already?
Hang on, I'll do it now. 2.9 centimeters per second.
Yeah.
Yeah, that's right.
So it's 14.5 divided by 5. Yeah, 2.9.
Yeah. Okay, yeah, that makes sense.
That makes sense. All right,
Yeah.
next question.
That's actually it. Those are the questions.
Okay.
Yeah.
What about Nimesha? Do you have some questions as well?
Yeah. Just for 18G.
18J.
Yeah. Question 5.
Yep.
Like
This one
I
here?
got little, yeah, that one. I got little bits of it, but just putting it all together kind of just confused me. Even when I was looking at the answers, it just, I don't know.
Okay, so it passes the 50th floor with a velocity of this much and an acceleration of this much. if each floor spans a height of 6 meters, find at which floor the lift will stop. Okay. So there's not, it seems like there is not enough information provided, so I think we have to make some assumption. The first question that I'm asking is, when does the time start? When does the time start? Does it start on the 50th floor? Or does it start from the 0th floor, first floor? So not much information is given.
You have to, this is just a guess, but do you have to anti-differentiate, maybe? I'm not sure. I haven't looked at this question.
Okay. First floor, there's first floor, right?
Yeah.
So first floor, so this is 6 meters. So I'm going to call this one x equals 0, and x equals to 1 is the second floor, start of the second floor. X equals 0 is the start of the first floor, okay?
Yeah.
So x is equal to 49 would be the start of the 50th floor, is it right?
Yeah.
It's actually 6 meters each. Hold on. So there's a lot of confusion here. Maybe let this equal to 6 here. Times everything by 6, okay? So x is equal to 12. That's 12 meters is the start of the third floor. And so 49 times by 6, that's equal to, I think, 294, I guess. 49 times by 6, 294. That's in meters, so that's the start of the 50th floor. So
why did you multiply it by 49?
Because it's so this is x equals 1. So first floor, how do I describe it? So x equals 0 corresponds to first floor, right?
Yeah.
And x equals to 6 corresponds to second floor, start of the second floor, right?
Yeah.
So what it means is this: if I divide this one by 6 and then plus 1 to it, that gives me the floor. If I divide this one by 2 and then plus 1 to it, then I get 3. True?
Oh.
So,
Okay.
so if I do 294 divided by 6 and then plus 1 to it, then I get the 50th.
Oh, because it starts from
So
0.
I have to go. So if I want to go backward, then I have to do 50 minus 1, so 49. Times by 6, then I get 294.
Yeah. Okay.
It's a little bit difficult to get all these numbers, but I'm still not sure where from where it starts. So acceleration is 1 on 9 t minus 5, right?
Mm-hmm.
Yeah.
So like initially it was accelerating backward, because when this is 0, you get negative 5 on 9. So you know how we talked about velocity forward, but the acceleration forward, then it's going to get faster.
Yeah.
Acceleration forward, but acceleration backward, velocity forward, then it's going to slow down.
Yeah.
If it's that way and that way, then it's going to get faster backward. But if it's that way and that way, but then it's going to slow down, right?
Yeah.
This is faster case, or this is a slowing down case. This is our acceleration. we're going to integrate this one. Then we get the velocity is equal to 1 on 9, t squared on 2 minus 5t plus c. Is that right?
Yeah.
But the problem is we don't know what c is.
Do we just use -8?
Well, that's going to be the velocity, but we don't really know.
Can you sub 50 in as a point? Like
50th floor, that's not really time. So this is in terms of time, isn't it? I'll have a look at this again in my own time and get back to you.
Okay.
Yeah.
Yeah.
Well, you guys can think about this. I'm just going to go to the bathroom quickly, all right?
Yeah.
Yep.
So I want you to look at the answer and see what it says first.
Okay.
Yeah. I'll be right back.
Animation. Oh my god, my questions. I did not know what I was saying. I was like, oh my god.
Yeah, like
But that's
I had
okay.
another one actually in 18th, but like I felt like this one was going to take some time, so I just like
Yeah.
asked this one first.
I haven't even looked at it.
I know, it's so confusing. Like, I get like that you can anti-differentiate all of them, and like you can find like I found the position and stuff, and for x, like for position, like you know when you anti-differentiate something, when you anti-differentiate velocity after you anti-differentiate acceleration,
Yeah.
you use 300 because like 6 times 50 is 300, and then so c would be equal to 300 when x of t, also when t equals 0. You know what I mean?
Yeah.
So like I'm assuming that for v for velocity, then it would equal -8. Because like there's no other information, so you can't really do anything else.
Yeah, but why would it be when v equals 0? It's -8 because it's like it's on the 50th floor. Like it doesn't really make sense. You know what I mean?
Yeah.
Like it's not like a turning point or anything. So velocity equals 0, gradient equals 0. Can Lomini do it? Do you know?
Oh, I reckon she has. She did 18H as well.
Are you serious?
Yeah, she wasn't meant to. Oh.
What?
Yeah.
What?
I
How?
almost started, and she did all the 17s as well.
Dude, she honestly should have stayed in spec.
I know. Oh my god, it would have been better for all our grades.
I know. Yeah, holy shit. Okay, you can talk to him when he gets back.
Like, I have the answer written down. It's just so messy.
Yeah.
Like, it's acceleration equals t minus 5/9. Like, that was just expanded. Therefore, velocity equals t squared over 18 minus squared over 9 plus c. And then it says that c was found by equaling it to -8. So therefore c equals a -8.
Yeah, I don't get that. Like, how do you know that's like a turning point? Wait, how do you anti-differentiate?
Anti-differentiate, you go, you add the power by 1, and then you divide it by that new power. So if it was 8t, you make it 8t squared over 2.
Okay, cool. Wait, so what were you saying about the turning point?
So like not the turning point, but wait, is C the turning point? No, not as in you equal it to 0, as in you make, you know how you can go v of t? So you make t equal 0 in velocity in the equation. and then you
Oh,
equal that to -8, and then that's how you get
okay.
that.
Okay, so this question was 18G, was it?
Yeah.
18J. Which question?
5.
So it only gives you one answer, 29th floor, right?
Yeah.
Um,
Oh yeah. Our school has given like other answers which are worked out.
okay.
So they did they anti-differentiated acceleration to find velocity,
Mm-hmm.
and then they made it plus c was equal to -8.
This was 8, is it?
Yeah, they made c -8 for velocity.
Okay, that means you start from the 50th floor.
Yeah.
Yeah, you start from the 50th floor, so that's when time is 0. When time was 0, you are at the 50th floor, so that information is missing, okay?
Okay.
And when time is 0, initially your velocity is -8. That makes sense now.
Okay. Yeah.
So now the velocity is -8 when time is 0, right? So you 1 on 9. This whole thing is 0 minus 0, isn't it?
Yeah.
0 square on 2 is 0. 0 times 5 is 0. So you get -8 equals c. Is that right?
Yeah.
Yeah. So this is how you get c equals -8. So your velocity is 1 on 9 t square on 2 minus 5t and then minus 8. So that's how you get the v.
Yeah.
Now, and then you, I think you, once you have that, because we're trying to find out, so we're not trying to find out the displacement, we were trying to figure out at which floor the lift will stop, right? At which floor will the lift stop? Actually, for that you need to anti-differentiate that too. So yeah, so the velocity is, this is a t square over 18. When you expand this one out, this is a 5 on 9t minus 8. So if you anti-differentiate that, so in the written solution, do you see the anti-differentiation again?
Yeah.
Yeah, okay. So x is equal to, so t 3 over 18 times by 3 is 54. That's 3 on 3. And then the 5 on 9 t square on 2. So that's equal to 18 here. And 8t and then plus c, right?
Yeah.
So initially, so we have to be careful because the velocity was in meters per second. Acceleration was also meters per second square. So we need to find c here, right?
Yeah.
So if you plug in 0, 0, 0 here, you cannot actually plug in 50 here because 50 means 50th floor, right?
Right. Yeah.
Yeah, so that's the problem. So I would rather plug in 249. That's what you have to do. Is that what they did?
They just made it equal to 300.
300 instead of 249.
Yeah.
So it really is up to you. So I use this convention here.
Yeah.
But you still get the same thing. So in the answer sheet's case, they let 50th equal to x equal 300.
Yeah.
And probably first floor is x equals 6. So you start from 6 and then 12 and then 18 and things like that.
Yeah.
So let's actually follow that one. So
yeah.
So there must be 0th floor as well. So 0th floor is x equals 0. X equals 6 means first floor, so that we're going to use this convention here. So that's 300.
Yeah.
So time is 0, 0, 0. Then x is equal to 300. So therefore c is equal to 300. Then your x is equal to t3 on 54 minus 5 on 18 t squared minus 8t plus 300. And once you have that, we just have to find time when this thing stops. So this is velocity, right? Let this equal 0. I'm just going to use my calculator. So you guys have one of these, right?
Yeah.
So something similar. So I'm just going to solve this quadratic equation. This is a quadratic equation equals 0. So I'm going to write 1 on 18 here, and then negative 5 on 9, and then minus 8, and see when this velocity becomes 0. That's when it stops. Solve, and I get time equals 18 seconds. Or negative 8, but we don't consider negative time, right?
Yeah.
So time is 18 seconds from this one here, and you plug this into this equation, this one here.
Yeah.
Then you find the x, but you have to translate that into a floor.
Yeah.
Oh, it's 18 to the power of 3 over 54 minus 5 times by 18 square over 18 minus 8 times by 18 plus 300. Then you get 174. Now divide that by 6, then you get 29.
Yeah.
Okay.
I see.
So this was actually such a complicated question, but such a little information given.
Yeah.
It's just 2 sentences here. It's just they should have provided more information and maybe even a diagram as well.
Yeah.
That would have been a lot more helpful. So yeah, that's the answer. Shall we do one more question maybe?
Yeah. Back to 18F. Question 12E.
Yep.
I just didn't know how to do it.
18, is it?
Yeah.
There was 18.
So question 12E.
This one here?
Yes.
Okay, so particle moving in a straight line has a position x. This is the position, and that's a cubic equation. So, did you say F?
E.
Okay. Before we do this one, we need to talk about quadratic inequality, okay?
Okay.
Quadratic inequality. So if you have x minus alpha, x minus beta greater than 0, and you have this situation, and let's say this is alpha and this is beta, then you solve this one by this is greater here, this is greater here, right?
Yeah.
So the answer is x is less than alpha or x is greater than beta.
Yeah.
Now if you have situation like x minus alpha, x minus beta, but then you have minus sign, and that's greater than 0, that means you have an upside down parabola. And this is alpha and this is beta. Then you have it's greater than 0, so that's greater than 0 here, right?
Yeah.
So x is between what? Beta and alpha. So that's the answer for this one and this one, okay?
Okay.
Now if you have this same situation, but it's less than 0, so if it's less than 0, then you have to go for this part here, which is x is between beta and alpha. So if you have less than 0 case, then you have this bit and this bit here. So that's x is less than alpha or x is greater than beta. Understand?
Yeah.
Now, we have this velocity. Velocity is equal to 3t squared minus 22t plus 24. Is that right?
Yeah.
If we factorize this one, I'm just going to let this equal 0.
Yeah.
And I'm not going to bother factorizing. I'm just going to use my calculator. Equation here. Polynomial degree 2. Just going to type 3 minus 22, 24. Solve. Like 6 and 4 and 3. 6 and 4 and 3. 6 here and 4 and 3.
Yeah.
So probably this one factorizes into 3x minus 4 and then x minus 6.
Yeah.
That one here factorizes into this one. And it's going to be a parabola like this one or upside down parabola. Which one?
Parabola the other way.
The other way.
Yeah,
This one
like
here, right? Like that. Okay, so we want this velocity actually to be greater than a negative, actually. Negative, right? So we want this to be negative. So we solve for this point and this point by letting this equal to 0. Is that right?
Yeah.
Once you have these points, then you change this one to this one because that's what you want here, right?
Yeah. Yeah.
So what's the answer then? Time is, this is actually t here, sorry. That's t and x. You can find out the answer. I'll give you some time.
Wait, can you just look at the graph and?
Yeah, you can just look at the graph and figure out. Hold on, by the way, this is not the displacement versus time graph. This is a velocity versus time graph, isn't it? I just graphed this one. All right? So this is totally different from x versus t, okay?
Okay. Yeah.
X versus t, you can like figure out distance from it, but with this one, you cannot figure out displacement or distance, anything like that. This is only about this velocity. Now you can see that the velocity is positive here and here, right?
Yeah.
Negative here. See?
Yeah. Oh, okay.
Same thing as this one. So what must be the time so that the velocity is negative? It's between what? 6 seconds and 4 and 3 seconds.
Yeah.
So do you want to check the answer? 12, this is 18F, 12, right? 12. Yep, 4 and 3 seconds, 6 seconds, right?
Yep.
Hold on. That's between, right?
Oh, it's E.
E.
Yeah. Okay. Cool. That's what I.
It's a duration, is it?
Yeah. So I just did 6
so
minus
6 minus 4 and 3. Yeah.
Yeah. Cool.
So they're talking about duration of it. So yeah. For how long? Yeah, is the particle negative?
Cool.
Yeah. Everything else was okay?
Yeah, that was so good.
Yep. All right, shall we call it a day?
Yeah, sure.
All right, just let me know through the Facebook Messenger if you want some written solution or explanation. Let me know.
Yeah.
Okay,
are you able to send us the video?
Yeah, of course. Did I send you the last video?
Yeah, you did. It was great.
Yeah, I'll send you both this working out and also the video. Okay. I'll see you next time.
Awesome.
Okay, thank you.
Bye.